Welcome back. In this lesson, we are going to learn how to solve a category of bugs that has caused serious failures in many systems. Have you ever heard of the Mars climate orbiter crash? A simple unit mismatch led to the complete loss of a spacecraft. What we are about to learn today is incredibly important if you want to build truly production-ready systems that catch these kinds of fatal errors before they ever run. To understand how catastrophic these bugs can be, imagine mixing up miles and kilometers, like the Mars climate orbiter team did. In software, mixing up two identical data types that represent entirely different concepts is a silent killer. Let's look at how this happens in TypeScript. Here we are, starting with a blank slate in our editor. Let's define a type alias. Type user ID equals string. And right below that, type post ID equals string. Now, let's create a function to handle deleting a post. Declare a function named deleteUserPost. We will give it two parameters, user ID of type user ID and post ID of type post ID. Inside the function body, let's add a simple console log, executing delete, passing in our user ID and post ID variables. Down here, let's simulate some incoming data. Declare a constant incoming post ID of type post ID and set its value to the string post_123. Next, declare a constant incoming user ID of type user ID and set its value to the string user_123. Now, let's call our function. Type deleteUserPost and pass in incoming post ID first, then incoming user ID. Notice anything wrong? We passed the post ID where the user ID should be, and the user ID where the post ID should be. But TypeScript is perfectly happy with this and allows the mistake, because both are ultimately just strings. This is exactly the kind of silent failure that brings down production systems. To fix this, we are going to use a powerful pattern called branded types. This will allow us to trick TypeScript into treating these identical underlying types as completely unique. Let's go up and modify our types. Type, declare constant user ID brand, unique symbol. A unique symbol in TypeScript is a special built-in type that represents a globally unique identifier. It guarantees that no two symbols are ever the same, making it perfect for tagging or branding our types. Now, we will update our user ID type. After string, type an ampersand to create an intersection. Then open an object type, type read-only, open brackets, user ID brand, type of user ID brand. Let's break down what we just did. We declared a unique symbol that acts like a secret, one-of-a-kind tag. Then we used an intersection type, that ampersand, to tell TypeScript that a user ID is not just a string, but it is a string that also contains this invisible unique tag. At runtime, it is still just a normal string, but at compile time, TypeScript sees a completely unique entity. You might be wondering about that read-only keyword. We use read-only on a brand to signal that it is an internal, immutable marker. It is not strictly required for type safety, but it prevents accidental mutation and clarifies our intent that this tag should never be changed. Let's do the exact same thing for our post ID. Type declare constant post ID brand, unique symbol. And update the type. Type post ID equals string, ampersand, open braces, read only, open bracket, post ID brand, type of post ID brand. Now look down here at our function call. See this red squiggly line under incoming post ID? TypeScript is stepping in and refusing to allow this mistake anymore. So let's fix it by passing in the correct variable. Change the first argument to incoming user ID. But check out the second argument. We currently have incoming user ID sitting in the spot meant for a post ID, and TypeScript is throwing an error here too. It knows they are not interchangeable anymore. Let's correct that by changing the second argument to incoming post ID. Now, if we look right above our function call at our variable declarations, TypeScript is complaining about assigning these plain strings directly to our branded types. Why? Because a plain string does not have that invisible, unique symbol tag we just created. To resolve this, let's remove the explicit post ID type annotation from this line. And let's also remove the user ID type annotation from the incoming user ID variable. But look what happens to our function call now. TypeScript is complaining again, saying the argument of type string is not assignable to the parameter of type user ID. Since we removed the explicit types, these variables are just regular strings again, and our function strictly requires those special branded types. So how do we turn a regular string into a branded type? We need a way to safely validate and cast our data. We are going to build a validation function to handle this transition. Let's write that function. Type function validate user ID, taking an ID parameter of type string and returning a user ID. Inside the block, type return ID as user ID. We are using a type assertion here to tell the compiler to trust us that this string is now fully branded. Down where we define incoming user ID, let's wrap our string in that function. Type validate user ID, open parentheses, pass in our string, and close parentheses. We will do the exact same thing for our post ID. We define a function validate post ID, taking an ID of type string and returning a post ID. Inside, we just type return ID as post ID. Finally, let's call validate post ID and pass in our post_123 string. And just like that, TypeScript is happy, the errors are gone, and our code is completely secure. Now, in a real-world scenario, since these are strings, you would likely add actual runtime checks inside those validate functions. For instance, you could check if the string actually starts with post_ or user_ before returning it. But our main goal today was simply to understand the immense power of branded types at compile time. This branded type pattern is not just for strings. You can use it in many other scenarios, like differentiating between two variables representing kilometers and miles, which are both technically just numbers under the hood, but absolutely should never be mixed up. To wrap up, a branded type is simply a way to attach a unique, invisible label to a primitive type, so TypeScript can tell them apart. You should think about using branded types whenever you have identical underlying data structures, like strings or numbers, that represent entirely different concepts in your business logic. It is a fantastic tool to guarantee that your functions only ever accept exactly what they are supposed to.